Hello and welcome to this video on complex numbers. This is the 34th set of problems on complex numbers. Special welcome to those who are new to the channel. If you are new to the channel, please subscribe to the channel and press the bell icon so that you can get notified about more videos on complex numbers or other upcoming videos which I make. So with that out of the way, let's get started. We go to slides. Algebra, complex numbers, problem 331. So as I always say that when I'm reading the problem, you should pause the video, and if you cannot solve the problem, only then look at the solution. So question 331 says that solve the equation 2 square root of 2 x to the power 4 is equal to square root of 3 minus 1 plus I square root of 3 plus 1. So we write it like that: x to the power 4 is equal to root 3 minus 1 by 2 root 2 plus root 3 plus 1 by 2 root 2. There is a missing I here. There should be I here. In polar form, we write it in polar form. So x to the power 4 is equal to 5 pi by 12 plus I sine 5 pi by 12. So from this, we find x as cos 24r plus 5 into pi by 48 plus I sine 24r plus 5 pi by 8, where r is 0, 1, 2, 4 and so on. Question 332 says that if zr is equal to cos pi by 3 to the power r plus I sine pi by 3 to the power r, prove that z1, z2, z3 up to infinity is equal to I. So we write the left hand side z1, z2, z3 up to infinity as cos pi by 3 plus I sine pi by 3 into cos pi by 3 square plus I sine pi by 3 square into cos pi by 3 cube plus I sine pi by 3 cube and so on. Now you know that, say we have two complex number cos theta plus I sine theta and cos phi plus I sine phi, and if we multiply them, then the result is cos theta plus phi into I sine theta plus phi. So all these terms pi by 3 square, pi by 3 cube will get added. Now you see this is an arithmetic geometric progression with first term pi by 3 and common ratio 1 by 3. So sum of infinite geometric progression is a by 1 minus r. So it becomes cos pi by 3 by 1 minus 1 by 3, that is 2 by 3. The denominator is 2 by 3. 3 will get cancelled. It will become cos pi by 2, and similarly I sine pi by 2. So I sine pi by 2 will become I, and cos pi by 2 is 0, which is our right hand side. Question 333 says that if cos theta plus I sine theta is a solution of the equation p0 x to the power n plus p1 x to the power n minus 1 plus p2 x to the power n minus 2 and so on up to pn, prove that p sine theta plus p2 sine 2 theta plus up to pn is equal to 0, and p0 plus p2 cos theta plus up to pn cos n theta is equal to 0, where pi belongs to the set of real numbers I is 1 to n. So we are given this and we have to prove this. So what we do is we substitute x is equal to cos theta plus I sine theta. So it becomes p0 cos n theta plus I sine n theta plus p1 cos n minus 1 theta plus sine n minus 1 into theta and so on. So now we divide this by cos n theta I sine n theta, and so the equation becomes p0 plus p1 cos theta minus I sine theta plus p2 cos 2 theta minus I sine 2 theta and so on, and then you equate real and imaginary parts and you will get the desired solution. Question 334 says that show that 1 plus cos phi plus I sine phi by 1 plus cos phi minus I sine phi whole to the power n is equal to cos n phi plus I sine n phi. There is a missing n here. So our left hand side is we rationalize this given fraction. So our numerator would be 1 plus cos phi plus I sine phi into 1 plus cos phi plus I sine phi divided by 1 plus cos phi whole square plus sine square phi. Now numerator is nothing but 1 plus cos phi plus I sine phi whole square, which becomes 1 plus 2 cos phi plus cos square phi minus sine square phi plus 2I sine phi 1 plus cos phi, and denominator becomes 1 plus 2 cos phi plus cos square phi plus sine square phi. So we simplify this, it becomes 2 cos phi into 1 plus cos phi plus 2y sin phi into 1 plus cos phi whole to the power n, which is equal to cos phi plus I sin phi, okay, and whole to the power n, which is equal to cos n phi plus I sin n phi. Question 335 says that if to let's revisit this problem again. So this becomes 2i sin phi and 1 plus cos phi sin phi by tan phi. I think there is something wrong in this problem. See, cos phi, 1 plus cos phi will get cancelled with this. So this would be 1 and this would be tan phi, 1 plus tan phi, 1 plus I tan phi. So that would be sine plus cos by cos. There is something wrong here. This is cos square minus sine square phi, and this is 2 cos square phi plus 2, okay, 2 cos square phi plus 2. So okay, 2 cos phi into 1 plus cos phi. This would be 2 plus 2 cos phi. This cos phi is extra. This is not correct. This won't be there, okay. This is a calculation mistake or typing mistake. This cos phi will not be there, and then it will work out. Question 335 says that 2 cos theta plus is equal to x plus 1 by x and 2 cos phi is equal to y plus 1 by y. Then prove that x by y is plus y by x is equal to 2 cos theta minus phi. Xy plus 1 by xy is equal to 2 cos theta plus phi. X to the power m y to the power n plus 1 by x to the power m y to the power n is equal to 2 cos m theta plus n phi. And x to the power m y to the power n plus y to the power n x to the power m is equal to 2 cos m theta minus n phi. So we are given that 2 cos theta is equal to x plus 1 by x. So x square minus 2 cos theta x plus 1 is equal to 0. That means x is equal to cos theta plus minus I sin theta. Similarly, y is equal to cos phi plus minus I sin phi. Now it's a matter of simply substituting these in the given expressions and we will have the result. So x by y is cos theta minus phi plus minus I sin theta minus phi, and y by x would be cos theta minus cos phi minus theta plus minus I sin phi minus theta. So sine terms will cancel each other and our result will be 2 cos theta minus phi, because cos minus theta is equal to cos theta and sine minus theta is equal to minus sine theta. This is fourth quadrant we are talking about. Xy will be cos theta plus phi plus minus I sin theta plus phi, and 1 by xy would be cos theta plus phi minus plus I sin theta plus phi. Again the sine terms will get cancelled and the result will be 2 cos theta plus phi. X to the power m y to the power n would be cos m theta plus minus I sin m theta into cos n phi plus minus I sin n phi. That is cos m theta plus n phi plus minus I sin m theta plus n phi. And similarly 1 by x to the power m y to the power n would be cos m theta plus n phi minus plus I sin m theta plus n phi. So left hand side will be equal to 2 cos m theta plus n phi is equal to right hand side. X to the power m y to the power n is equal to cos m theta minus n phi plus minus I sin m theta minus n phi, proceeding like previous problems. And y to the power n x to the power m would be cos n phi minus m theta plus minus sin n phi minus m theta. Again sine terms will get cancelled and left hand side will be equal to 2 cos m theta minus n phi, which is our right hand side. Question 336 says that if alpha beta are the roots of the equation x square minus 2x plus 4 is equal to 0, prove that alpha to the power n plus beta to the power n is equal to 2 to the power n plus 1 cos n pi by 3. So given equation is x square minus 2x plus 4 is equal to 0. So we find out the roots alpha beta, which will be 1 plus minus I square root of 3. We convert this into polar forms, which will be 2 cos pi by 3 plus minus sine I sin pi by 3. So alpha to the power n and beta to the power n both would be 2 cos n pi by 3 plus minus I sine n pi by 3. So we add both of them, sine term will get cancelled and we will be left with 2 to the power n plus 1 cos n pi by 3, which is our right hand side. Question 337 says that find the equation whose roots are nth power of the roots of the equation x square minus 2x plus cos theta plus 1 is equal to 0. So once again the roots would be cos theta plus minus I sin theta, and nth power would be cos n theta plus minus I sin n theta, and sum of the we have to find the equation. So sum of the roots would be 2 cos n theta and product would be 1. So the equation would be x square minus 2 cos n theta plus 1 is equal to 0. Question 338 says that find the value of a and b where a e to the power 2I theta plus b e to the power minus 2I theta is equal to 5 cos 2 theta minus sin 2 theta minus 7 sin 2 theta. So left hand side is a cos 2 theta plus I sin 2 theta plus b cos 2 theta minus I sin 2 theta, that is 5 cos 2 theta plus 7 I square sin 2 theta. So from this we gather that a plus b is 5 and a minus b is 7i. So a is equal to 5 plus 7i by 2 and b is equal to 5 minus 7i by 2. Question 339 says that if x is equal to cos theta plus I sin theta and square root of 1 minus c square is equal to nc minus 1, prove that 1 plus c cos theta is equal to c by 2 and 1 plus nx into 1 plus n by x. So we square the second equation, we get n square plus c square. This should be minus 2nc. No, this is plus 2nc. How come? Oh, we have brought it to left hand side? No. So this we square. So this would be n square c square plus 1 minus 2nc, and this would be 1 minus c square. So we bring it to right hand side, c square will be positive. This should be minus 2nc. Yeah, this will be minus 2nc. It's a typing mistake because 2nc will go on right hand side. So it will be c is equal to 2n by n square plus 1. Now we have to prove that 1 plus cos theta is equal to c by 2n into 1 plus nx into 1 plus nx. So we proceed from right hand side, we get 1 by n square plus 1. We substitute c is equal to 2n by n square plus 1, and n will get cancelled, 2 will get cancelled. So this is equal to 1 by n square plus 1, and these two we multiply. We get 1 into 1 1, nx into n by x as n square, and this would be nx plus n by x. Okay, so nx plus n by x, we substitute cos theta plus I sin theta and we get this, and then we have 1 plus the product as 1 plus 2n by n square cos theta, but 2n by n square plus 1 is c, so it is equal to 1 plus c cos theta. Question 340 says that show that the roots of the equation 1 plus z to the power n is equal to 1 minus z to the power n are I tan r pi by n, where r is equal to 0, 1, 2 up to n minus 1, excluding the value when n is even and r is equal to n by 2. So we are given 1 by z plus divided by 1 plus z by 1 minus z whole to the power n is equal to 1. So 1 plus z is equal to 1 minus z cos 2r pi by n plus I sin 2r pi by n. Now we let 2r pi by n is equal to theta. So 1 plus z is equal to 1 minus z into cos theta plus I sin theta. So by solving this equation, we get z is equal to cos theta minus 1 plus I sin theta divided by 1 plus cos theta and plus I sin theta. So from this we get z is equal to I tan theta by 2. That is I tan 2 pi by n. Now r is equal to 0, 1, 2 up to n minus 1. Now clearly this equation is invalid if n is even, okay, and r is equal to n by 2, as it will cause the value of tan function to reach infinity. So with this we come to the end of 34th set of problems on complex numbers. There are 3-4 more sets possible. There will be 4 more sets I believe on complex numbers, but that does not mean that that will be the end of complex numbers. As I have said, at the end of arithmetic progression, once we finish all of algebra, I will present a miscellaneous problems set which will contain far more difficult problems, advanced problems on mathematics. So I hope that you have found this video useful. Please share the video on social media as much as you can. Like the video, make use of the comment box to interact with me, and let's discuss what other things we can do together. For example, videos on physics or chemistry, and I'll see how I can accommodate that. In any case, thanks a lot for watching. Have a nice day.